In this video, I'm going to show you some useful features of the EDR Exchanger. To edit or modify a rigorous EDR Exchanger, you may click on the hyperlink HeatX in the Exchanger Summary Table tab window. Remember, the Exchanger Summary Table tab window is accessed via clicking on the EDR Exchanger Feasibility panel on the Activation dashboard. So now, to edit or to modify the rigorous EDR Exchanger, click here on the hyperlink HeatX. Once you do that, you will have access to the EDR navigation pane and the corresponding tab sheets, as you can see here. Using the EDR navigation pane, you may modify any entry. Keep in mind though that if you modify any of the geometrical entries, then you have to rerun the simulation via clicking on the next button that you can see here, while the EDR Exchanger design is in connected mode as highlighted here. For example, you may change the number of tubes from 56 to a higher number, let's say 70, to increase the surface area available for the heat exchanger. The effect of changing any of the input parameters on exchanger performance can be seen via browsing through different results sheet in the EDR navigation pane. Remember to always check for the adverse effects on exchanger performance via monitoring the errors and warnings tab form. Okay, now switch back to the main flowsheet window. At this stage, you can click on the small button at the lower right of the dashboard panel to highlight exchangers on the flowsheet by clicking on Show Model Status, which marks whether exchangers are simple or rigorous, or by clicking on Show Risk Status, or by clicking on Show Legend to display the meanings of the colors. When Show Risk Status is active, if you move the mouse over one of the flowsheet highlights, like this, information appears about the risks in a small window. Operational or performance warnings are shown with a yellow status icon. Operational or performance risks are shown with a red icon. The most severe risk type is indicated at the top of this window as the overall exchanger status. So click here on the overall exchanger status icon to display more details about the risks. Now, so that you are aware, you can revert to the simple shortcut method by clicking on Revert to Simple button, as you can see here. An alternative method to revert to the simple shortcut method is to go to Blocks, Heat Exchangers, Setup, Specifications tab window. When the results are available for a rigorous exchanger type, you can click on the button Reconcile that you can see here to switch this block back to a shortcut model. Finally, keep in mind the Reynolds number for both sides of the exchanger can be seen in EDR navigation panel in Thermal Hydraulic Summary, Heat Transfer Coefficient tab window, as you can see here. Now, I emphasize on Reynolds number for a very simple reason. What I want you to understand and to keep in mind after this section is that to obtain an economic heat exchanger design, high heat transfer coefficients are needed, and these coefficients are much higher for turbulent flows than laminar. Turbulent flows correspond to high Reynolds number. Lastly, in addition to the heat transfer coefficient and Reynolds number, there is a third key parameter that needs your attention. This is the pressure drop. In general, there is a trade-off between having a higher heat transfer coefficient needed for an economic design and a lower pressure drop. This simply means that tightening on the fluid will result in a higher heat transfer coefficient, but with a higher pressure drop at the same time. So the heat transfer can be further improved until we hit the upper limit of pressure drop for both exchanger sides.